Hello, everyone. Hope you're all doing well today. We've got stuff to cover, so we should get to it. But before we do, I would like to say a couple of notes very quickly. First of all, can we have a whoop whoop in the chat, please, so that I know that you guys are alive? I currently only have 6 people viewing this. I'm assuming it's been it's gonna be quite the week for you guys. Oh, we're up to 8. Yup. So maybe we'll just give people a minute or two to get into the lecture, since, you know, I get it. I do. Oh, there we go. Thank you for the whoop whoop. I appreciate it. Yeah. So it's snowing in Hamilton today. I'm really looking forward to having to shovel my driveway today. It's terrible. I've got like a double wide driveway, which is lovely every time of the year except winter. And the my next door neighbor is like a 90-year-old old lady who, you know, normally I do hers too, but, you know, it's, you know, out of neighborliness. But, you know, that means that I'm shoveling basically 3 driveways, not including sidewalk, and we're a corner lot, so, jeez. Oh, hello, Remy. Hello, Remy. Say hello to the stream. Hello to the stream. I am the Remy cat. I have lots of opinions, but I keep them to myself most of the time. So, how are we doing? How are people? Are people in? Yeah, okay, that's enough. There are a couple of things that I'd like to talk about before we get into the lecture. Whoop, whoop, woo. That probably looked cool. Let me see that. Number 1, I wanted to talk about assignment 5. One of your colleagues has, whoop, there she goes. One of your colleagues has asked very politely for an extension on assignment 5, 2-day extension, and I don't see any reason not to grant a 2-day extension on assignment 5. So if you've seen the announcement feed today, you'll have noticed that an extra 2 days has been tacked onto the end of assignment 5. So, use it wisely. But yeah, aside from that, it probably would be just a good thing to review how the next couple of weeks are looking. So we have 3 lectures left, I believe, because I think the last day of the classes is the 7th, right? So we'll have a class on Monday, or no, we don't have classes on Monday. Sorry, we have classes Tuesday, Thursday, Friday. So Tuesday, Thursday, Friday will be it, and then we're done. Normally, I like to make the last day of class like a general Q&A review session. So if you have any questions of topics that you'd like reviewed from over the course, please please save those questions for Friday's lecture. We'll put some time aside specifically for that. The topic, the material that we'll be covering before the end of the course, is on the subject of how to put classes together inside of C++. We're going to see how far we can get with it, really. Today we're going to talk about composition and get into inheritance. Yeah. So anyway, are there any questions about how things are going over the next few weeks? Our exam isn't till the 22nd, which is quite a ways out, although not as long as you think it is. So, you know, hopefully, by the time the 22nd rolls around, all of you will be studied up. That's probably going to be close to the last exam that you guys are having. You know, considering that's like only 3 days before Christmas. But I don't know. I think occasionally I think they've had an exam on the 23rd. I think they scheduled exams for the 23rd, but I'm not sure. But anyway, yeah. So that's how things are going. Good. So let's just get right into our material for today then. Last time we finished off topic 10, right? So today we're going to be getting into a brand spanking new set of lecture slides. Topic: object-oriented programming in C++. So the last time was Intro to C++, where we defined classes. But this time what we're going to be doing is we're going to talk about some of the more traditional topics in object-oriented programming. Now, for those of you who wish to at some point gain employment, programming for a living, my understanding is that these types of questions are often the type of conceptual knowledge that will be expected of you within the context of an interview. So it would be cool, very cool, for you to, you know, give this material a certain amount of, Is this do I really only have that? I thought I did more in the inheritance side. Let me just quickly see if I can compile, if this is the most recent version. Compile. Oh, yeah, so in case you guys are interested, this is the document creation system that I've been using to create the slides. This is called LaTeX. LaTeX it's a little bit like HTML, but it's got a lot of other things in it as well. Okay. Yeah, nope, alright. No, we're up to date. Okay. I just wanted to check that. So, cool. The slides on Avenue only have... yeah, okay. Let me just throw that up there quickly. Thank you. Thank you for noticing. Man. It's entirely possible that those might not even... That might be the old version of topic 11, which I ended up sticking on the end of topic 10 as well. Let's see. Should be updated now. Yep, there we go. All right. So, so let's get into it. Object-oriented programming. So, in this lecture, we're going to be talking about some advanced topics in class organization, namely composition, inheritance, and polymorphism. We'll start with composition, which is the easiest one conceptually. You probably already know what it is and have used it many times. We're just kind of taking the idea and giving it a slightly more formal treatment than you might otherwise be used to. So, class composition is when classes have objects of other classes as members. So, if, like we're going to do an example in a few slides, where we use the point class that we defined in the previous set of lecture slides as a base class out of which we build a triangle class, which is, you know, the geometric figure of a triangle. Class compositions can form hierarchies of subclasses and superclasses. So, when you have taken, when you have composed a class out of other classes, this implicitly creates a hierarchy. if you have worked in sort of programming type systems where you're modifying objects in an object-oriented way without necessarily realizing that that's what's going on, then this is sort of implicitly the way that most things occur. For me, the go-to analogy for this is Unity, which is a game engine which I have been known to fiddle around with upon occasion. Within Unity, Unity games are organized primarily into scenes, but a scene is then broken down into an object hierarchy. They call them game objects, but they're objects in an object-oriented sense. So you have the scene itself, which could be considered the root object, which contains all of the rest of the objects. Then you would have, in the example of a pinball game, you would have a round bumper object, which would be an object within the object hierarchy. That round bumper would have sub-objects within it, things like the sprite, the animation controller, the script that determines the behavior of the bumper. All of these things are sub-objects that are contained by the super object, which is the round bumper. Because it's been organized into this manner, hierarchies are an extremely useful abstract conceptualization, because, in order to modify large numbers of sub-objects, it's only necessary to modify the superobject. And in some cases, the superobject itself doesn't even require... it doesn't need to do anything. Sometimes just containing a bunch of sub-objects is enough functionality for the superobject to warrant its existence. So, yeah. Hierarchies are extremely useful and important. In the following example, we use composition to construct a class for triangles from the class we defined for points in Topic 10 with some modifications. So let's recall our point class from Topic 10. In geometry, certain types of figures may be defined by a collection of points. The triangle class is going to be defined using class composition. When classes use objects of other classes as member data, this is called composition. A triangle has 3 points, so our triangle class will contain 3-point objects. For this example, we won't make too big of a deal out of private versus public variables. So here we go. We have, we're using math.h in this particular case because we're going to have to take square roots. But we have defined class point. It has 3 doubles, x, y, and z. We initialize those using the constructor, using the initializer list. We also have a distance to method defined. All this does is it takes the Euclidean distance between 2 points in 3-dimensional space, which is the slight adaptation of Pythagorean theorem to 3-dimensional space that you guys should be familiar with. Once again, returns something of type double, and it takes an object of type point. So there you go. In addition to this, we define a class for triangles. This has 3 public data members, all of which are objects of the point class, A, B, and C. The triangle is initialized with objects of the point class. So, the point A, point B, and point C are, you initialize them first, and then you provide them to the triangle, as we're going to see in the main method. Within this triangle class, we also have an area method, which calculates the area of the triangle using Heron's formula. You guys are probably more familiar with base times height divided by 2. But of course, if you have a triangle as defined by 3 arbitrary points in space, it's a reasonable amount of math to calculate the height in particular, because you need like the altitude of the triangle, and it's a somewhat complicated, not too complicated, but a somewhat complicated calculation. Instead, we use Heron's formula. Heron's formula is you calculate the semi-perimeter, which is actually just half of the perimeter. We have defined semi-perimeter as a private method because, in theory, the semi-perimeter is not useful to anything aside from the calculation of area. So it doesn't need to be external. But the semi-perimeter is just the distance from A to B plus the distance from B to C plus the distance from C to A divided by 2. So, perimeter divided by 2, semi-perimeter. We then take distance AB, BC, and CA. Again, distance. We're invoking the distance method. And according to Heron's formula, we're looking for the square root of S times S minus AB times S minus BC times S minus CA. And there you go. That's the area. So, in main, we define a triangle object using the triangle initializer. Within that triangle initializer, we are putting the constructors for the point class directly. So you don't actually have to save those to a separate location. You can actually modify them directly. You can insert them directly into the constructor. Constructors of constructors. And then see out the area of the triangle is t.area. If you take a look at what that looks like in geometric space, this is the triangle that we have defined according to these coordinates. And the area of said triangle is 6. As we can see, using an object within a class is the same as using it anywhere else. Composition produces a hierarchy of objects and introduces the idea of parent and child classes. A child object must be initialized via the initialization list. See Topic 10, Slide 37. Most of the time, when you're... so I should dwell on that point just for a moment. So, these guys may only be initialized in here. You can't do it in here. So, best to learn how to do this. It's not that hard. Hopefully. Most of the time, when you are working with object hierarchies in computer programs, you are working with a compositional hierarchy. So, one of the things that we're going to try to illustrate over the next couple of lectures is the differences between inheritance and composition, because they are different things and they have different purposes, but they are often confused for each other. Are there any questions so far? I'll give you guys a moment to ask any questions if you have any. Can I get a thumbs up? So, let's expand this idea into tetrahedrons. So, we define a new class, class tetrahedron. Public, it contains 4 triangles, because a tetrahedron is, you know, a solid shape that's composed of 4. It's got 4 triangles as its sides. We're talking about D4s if you're a D&D type person. If you like your thank you, Anthony. If you like your you know, 1 second. We're talking about these guys. Tetrahedron. Whoop. Jeez. Tetrahedron. So, it contains 4 triangles. However, we're not defining it by defining triangles. If you notice on a tetrahedron, you can define a tetrahedron in space according to 4 points on the object itself. So, the triangles are actually composed from well, obviously the triangles are composed from the points, but in order to fully define a tetrahedron, we don't actually need the triangles, we can use the points. And points are a simpler class, so it's easier to define them. So, we are defining A, B, and C with constructors inside of the initialization list itself, which is good and useful. That's a useful thing to know how to do. We also define a surface area method, which takes all it does is it takes the area of A, B, C, and D and composes it into the surface area of the tetrahedron. So hopefully, by means of this example, you guys are seeing how powerful object-oriented is as a paradigm. Once you have defined what the area is of a class, that can be used to construct more complicated things reasonably easily. If you were given a set of 4 points, like a set of 4 coordinates, and you were asked, okay, calculate the surface area of the tetrahedron represented by these 4 points, and you just went ahead and did that without having defined the triangle class as an intermediary, it would be kind of painful. Like, it would be possible, but tedious, right? Because essentially, you'd have to have 4 instantiations of the of Heron's formula, and you would also have to have you know, a large number of you would only have to do a number of distance 2 calculations equal to the number of edges in the geometric solid. But, you know, that would be still a considerable number of distance calculations, right? And as you can see, in C++, the calculation of one of these is 4 lines of code, right? And the calculation of this guy, you know, you can shrink it down. This is somewhat verbose, but it's also readable. This is 6 lines of code, so you know, you can see how this adds up. And if you were to, you know, if you were to just write a algorithm that calculated it straight from the points, that would be, you know, long and tedious. The whole point of object-oriented programming and programming abstractions in general is to make your life simpler by not having to repeat things so much. Once you have tapped into the power of these abstractions, you will become a much more efficient programmer. So, the 4 triangles that compose a tetrahedron require some constraints in order that they might actually form a tetrahedron. So, the idea here is you don't get a tetrahedron by taking 4 arbitrary triangles in space, right? There are specific things that are true about a triangle that composes a tetrahedron, and we can express that in terms of the points. You know, the each each triangle that composes a face of the tetrahedron must share one edge with one other triangle that forms the tetrahedron, essentially. And if that's true of all of them, then you've got a tetrahedron. A tetrahedron only has 4 points shared among 4 triangles. Our class encoding allows a tetrahedron to be constructed from only its vertices, I think. That's incorrect in terms of grammar, via the construction of a data policy. So, the thing that makes this a tetrahedron is the manner in which the triangles are being constructed from the points. So, you can imagine that if you had a tetrahedron class that was, if you had a tetrahedron class that was, that had its triangles, the triangles that compose the solid, if they were just, they could be modified in any manner you wanted, irrespective of the points, irrespective of the other triangles in the solid, then, you could open this thing up, and you could have one of the faces over here, and the other one over there, and, the thing that makes it a solid is the fact that all of the faces are connected and continuous, right? So, you could easily construct a set of triangles that violates this idea. In fact, if you were to construct a tetrahedron in that fashion, it's entirely probable that that's what you would end up with, because it turns out that modeling solid objects using only the coordinates of their vertexes is actually a reasonably difficult thing to try to do. So, by having the thing constructed in this manner, and if we were to make a slight modification to this tetrahedron to make the actual triangles themselves private, and controlling the means of access of the points, we could make sure that regardless of the type of transformation that you try to perform on the points of the object, that it would still be a valid tetrahedron. So you could, for example, take one of the points and translate it around, and all of these triangles would be stretched accordingly, i.e. the point on the 3 faces that correspond to that point would be moved around. Of course, you'd need some way of referencing the points, but, so be it. You'd have to do a little bit of extra bookkeeping, but that bookkeeping would be hidden from the user. All the user would see would be the translate function. And that is, in fact, how a lot of these things actually work. So, yeah, tetrahedrons. So this diagram here is just an illustration of the object hierarchy, the compositional object hierarchy that exists within the tetrahedron. And this is a representation of a tetrahedron as an object in physical space. It took me too long to produce that diagram. I used Python because I don't have MATLAB installed on this computer, and I tried using Octave, and it's terrible. Python is easier than Octave. So, cool. So let's learn about friendship. This is a slight parenthetical note. In C++, there is the somewhat odd concept of friendship among classes. Friends get certain privileges, and I misspelled privileges. Oh well. Specifically, to access a class's private members. I'm not going to say the joke, but you guys can think the joke, and maybe that will be sufficient. A class may designate both functions and classes as friends. This is a somewhat controversial feature of C++ because it violates the principle of encapsulation. So, the principle of encapsulation, just to remind ourselves, is that if you have data, you want to keep that data hidden so that, design decisions or things that are likely to change don't affect the overall interface. But in order for it to be sort of encapsulated well, you have to minimize the amount of like it's almost like minimizing the surface area of the algorithm. You want to minimize the number of ways in which the algorithm can be interacted with. The problem with designating friends is that the friend extends that surface area of the algorithm, right? It makes larger the number of ways in which the algorithm can be interacted with. And particularly in the case of functions, it's not it's not obvious why you would write a friend function and not a method, right? Because the big distinguishing feature of having a friend function is that the friend function has access to the private members of the object or the class. So if you want to write a function that has access to the private members of the class, why wouldn't you just make it a method, right? But, you know, it's still interesting to cover, I suppose. It is up to a class to determine who its friends are. You can't force a class or a function to be friends with another class. This is interesting. It has an interesting analogy in human life. But essentially, the declaration of friendship between classes, between one class and another, is that if that occurs within the class that is allowing access to its private members. How to analogize? It's a one-way relationship, which is interesting because in human speak, friendship is not generally necessarily like the friendship is considered dysfunctional if it's if it exists in one way and not the other, but within a programming context, that is the default setting. You can do it by providing a function prototype or class declaration with the friend tag in the class you wish to give access to. So yeah, and the other point here is that you can't write a class or a function that's external to the class you want to be granted privileges to, and declare access to that class from outside of it. It has to come from within the class. If you could do that, then the idea of having private members would be almost completely meaningless. But yeah, so friendship is magic. Include IOStream. Class A has a private member queue and a public method, which is the constructor, which sets Q to 0. We are also declaring a friend class B. Class B has a private member B and a public method which shows A. It must be given a reference to an object of the class A. We're going to talk about this guy right here today. And it just writes it to the output, to cout. Cool. In main, we declare A, we declare B. B.showA. A is executed, and then we return 0, although it's not necessarily to return 0 in C++. And this is what's printed. Despite being a private member of A, B is given access to A's private member, Q. There we go. So, I forgot to change that. So, yeah. Any questions so far? If there are no questions, I would love to receive a thumbs up, but I'll give you guys a moment to ask questions if you have any. I thought we said that you couldn't make a class be friends with another class. So let me. Okay, that's a good point. Let's get into that and clarify it. So what I meant when I said that, maybe I worded it poorly. So in order for B to have access to the class A has to declare the friendship, right? It's not possible for the class B to make itself friends with class A by including, like, friend class A somewhere in here. That's not, like, that doesn't work. It's the class that is giving the privileges that has to declare the friendship. And again, friendship is a unidirectional relation. So, just because A has declared B to be a friend does not give A access to B's private member. In fact, why don't we, maybe I have, get it, friends.cpp. Let's actually run this example, shall we? And do some modifications. Oh, bloody hell. There we go. So, let's just execute that and make sure it works. Whoop. Ooh, interesting. I've got Unicode characters in there. That'll be a bit better. Cool. Should have a new line in there too. There we go. So there we go. Now, the thing is, if we wanted, for example, to... Let's say we copied this guy and tried to have the same thing happen over here, but with B. Let's see what happens. A dot show B, B. So first of all, we got a problem. B has not been declared. So that's, you know, that's like a function prototype thing, right? Yeah. Invalid use of incomplete type class B. So problem. This causes a problem, right? However, hopefully, if we declare a friend in class A, hopefully that fixes it. Nope. Interesting. Well, at any rate, I'm getting stuck on some sort of problem that I'm not familiar with because I'm not really a C++ programmer. But anyway, the idea is that it's a unidirectional relationship. So, there you go. So let's talk about that ampersand character. This guy right here. Do you remember passing by reference in C? I hope you do. In C, when we want to pass something by reference, what we do is we pass a pointer to whatever it is that we want to pass by reference. This isn't necessarily passing by reference in the proper sense. We are rather, or at least it's not passing by reference in the object-oriented sense. This is passing a pointer to an object. The pointer itself is having its value passed, so it's still passed by value. It's not true passing by reference. But, you know, it gets the job done. And this is the manner in which other programming languages, these are the steps that other programming languages abstract away in order to provide the functionality of passing by reference. So, in C, if we have a swap operation that takes x and y, and we declare q and r, when we swap them, we pass in the address of q and the address of r. However, in C++, you have the option of passing by reference more directly, rather than passing pointers. So you can still pass by pointers in C++. Because C++ is a superset of C, you still have the ability to perform these operations in C++ that you performed in C. It's totally still valid, 100%. However, you have this new option of passing by reference. So rather than having the asterisk character after the type declaration, you have the ampersand character after the declaration. And testing, testing, testing. Testing, testing, testing. You're going to hold it together for the last 3 minutes of class? Okay. Anthony says we're back. Looks like it's holding stable. See, they did do something to it, because when I get downtime, it's not as much. But it's not... That's probably as a result of improving the connection speed, but not, oh, bloody hell. Yeah, it's not... I'll just put another little call into my ISP, see if they actually send me a new modem this time. Oh, but if the connection's bad, then a new modem won't help, and it's like... Yes, it would! You malicious pieces of cartilage. Anyway, so... you know what? I think we're just gonna call it here. It's 12:19, and I'm sure you guys have better things to be doing with your day. So, if you have any questions, I'll take your questions, and if not, we'll end the stream here. When will assignment 3 and 4 solutions be posted? Weren't they already? I'll follow up. I'll put that on my list. Thank you for, thank you. Okay. Any other questions? Slides haven't updated. I'm afraid I'm going to have to beg to differ on that one, because this is definitely the updated version of the slides that I see. Are you sure you're looking at week 12, topic 11? Oh, maybe the link is broken. I'll try deleting it and re-uploading it. Delete. I think I'm gonna have to delete it outright. Delete! Try it now. Is it good? Yeah, I believe you, because I'm... Yeah, okay. Change file? Because, like, the topic here is different from the one listed there. Oh, I see. I need to update the title for this guy. Okay. Could you guys try again? See if that did it? Wonderful, wonderful, excellent, cool. That's weird. I had to... So, the way that Avenue works in the back end is kind of strange and terrible. It's like... It, like, abstracts away... Oh my god, shut up, me. It abstracts away, like, the storage of the file on the server from its appearance in this topic list, which I suppose makes a certain degree of sense. That's why when you click to delete something, it asks you whether you want to remove it from the remove it from the content but keep the file, or permanently delete both. So I think that what happened there is that it had, like, bad metadata that was associating it with a file in the root directory, so I had to change the directory, put it in a subdirectory to break the metadata sufficiently to be able to actually have the thing upload correctly. So, yeah, anyway. Yeah, anyway, take her easy, folks. Talk to you soon. Bye.